Well, hi there. Welcome to Unit 5, the fifth and final unit in microeconomics. In this video, we're going to learn about factor markets, do a little bit of a deep dive into the question of how much of one input to employ and how much of two different kinds of inputs to employ. Let's get started. Okay, so in this first section, I'm just going to quickly review factors of production with you. Remember that there are labor, land, and capital. We talked about those in Unit 1. Those are the inputs used to produce other things. And in this unit, we're going to use L for an abbreviation for labor. We're going to price labor with wages rather than prices. We use W. We're also going to abbreviate land sometimes with an L. Also, a lot of people just write the word land. It's not that long. We use price R for the word rent, and that's also true for capital. There's legacy reasons why we use that term. It doesn't necessarily mean that you're leasing the land or the capital. You could actually be buying it and paying what we call rent. But we'll just kind of say that these two words, wages and rent, are the stand-ins for price when we're talking about factors. So when we talk about factors, there's kind of two different sides to this, obviously, with supply and demand. Most of the time when we talk about factor supply, we're actually really dealing with labor. That's because land supply is perfectly inelastic, right? So land, we don't really talk about shifts because you can't increase the quantity regardless of the price. Capital, we do sometimes see an upward sloping supply curve when we have kind of an analysis of capital, but we very rarely talk about the supply of capital. For the most part, it has to do with kind of the other uses that capital might employ, and maybe also legacy investments in research and development, things like that. So we usually aren't going to be talking about shifting supply of land or capital, but we will talk about shifting labor. And labor supply comes from people being willing to sell their labor to, in other words, trade their leisure time for money. And so ultimately, it's really not about like the wages shifting it. So we don't want to say that wages shift the curve because they are part of the curve. When we say like wages are the price, we're actually saying that as the wages go up, as wages rise, people are willing and able to supply more of their labor. But that's not the overall supply of labor, right? You know, when we say like the supply of something changes, we're saying that at every single price that the quantity supplied is going to vary. And so a change in supply would be a shifter. That would be like something that increases supply and shifts the curve to the right. That could be maybe more immigrants, more babies, at least in the long term, right? Not immediately. Get to work, baby. So things that like could change everybody, like all of the whole economy. You have more people who are willing and able to work, or less people who are willing and able to work, right? If we're talking about leisure preferences, maybe people are beginning to prefer more leisure time instead of work, and so they decrease the supply of labor. Another is cultural norms. That's often related to women in the workforce. So if there's more women in your workforce, and that's kind of a cultural evolution that's happening in your country, you might see an increase in the supply and a shift to the right? But a change in wages would just move you to a different point on the curve. So we can say wages don't shift. Whoa, this is the first thing I'm writing today, and you can see wages don't shift the curve. It's not really working out very well. Wages don't shift the curve. Now, let's talk a little bit about factor demand, because it's actually simpler and more difficult to understand, actually. Factor demand comes from when firms want to hire or employ a factor. And so it only comes from them wanting to make something with it. So we call factor demand derived demand. We say that it's derived from the demand for the thing that they're producing. So if whatever they're producing, if there's very little demand for it, then there's very little demand for the people, the machines, and the land upon which that thing is produced. We wouldn't want that kind of worker that produces this thing if nobody actually wants the thing at the end of the day. So we call it derived. Now, factor demand is equivalent to this thing called marginal revenue product, or MRP. And I've given you what it is here. It's the marginal product times the price of the output. In other words, it's the value of that factor to the company. It's how much they're willing and able to pay for it, right? When you think about what you're willing and able to pay for something, the analogous concept for a firm would be we're willing and able to pay for a worker insofar as they generate money for the company. And we can calculate how much money they generate for the company based on how much stuff they produce. That's the marginal product, and the price of the stuff that they produce. So as a quick little question, if Jimmy makes 5 sandwiches an hour and each one sells for 10, what's his MRP? Well, the 5 sandwiches times the $10 means it's $50. But what happens if maybe we increase the price of the output good? Well, then he's still making 5 sandwiches, But imagine if it was $12 per sandwich, well, then his MRP is now 60. So just the price of the good going up 20% here made the demand for him go up 20%, right? The willingness and ability of people to pay for his work increased by 20% just because the price went up. And that shouldn't be like earth shattering, but it really represents that Jimmy's worth to the company is based on the price of the good that he's producing, right? If the sandwiches are 20% more valuable to sell, then he is 20% more valuable, right? That's his MRP. That's the demand for him. Likewise, we would say that if Jimmy all of a sudden could produce 6 sandwiches and we still sold them for $10 an hour, or sold them for $10, he would now still be worth $60. And so if we increased his productivity, right, the productivity by 20%, we went from 5 to 6, that would also increase the demand for Jimmy by 20%. So really fundamentally, the demand for workers or the demand for machines or land or anything, all of it's based on is the productivity of that underlying factor, the worker, the productivity of the land, the productivity of the machine, and the price of the thing that they're producing. That's it. That's the only two things. So if those two change, then the demand can change, but otherwise it doesn't, right? And so supply of labor is relatively kind of squishy. Demand is super simple. It's the productivity of the factor and the price of the good. Let's see how much of one type of input should we employ. So these two questions are how many of two inputs and how many of one input. These are very similar to the utility problems. Utility from 2.3, I think it was 2.3. And so similar to utility. And so you're going to notice that as we're kind of solving these, especially if you did really well with that. So how much of a one employee to employ, we need to know the MRP, the value of the worker, and we need to know something called the marginal factor cost. Now the marginal factor cost is a new concept, but it really just represents the additional cost of an additional factor, right? That's all it is the additional cost, marginal cost of a factor. How much should it cost to employ that factor? And we would want to hire inputs up to the point where the revenue product is equal to the factor cost. And generally speaking, in a perfectly competitive factor market, actually, it's not general, it's just true. In a perfectly competitive factor market, we can say that if you're paying your worker, say $30 an hour, right? You get $30 an hour, that's the factor cost because that's how much it costs to hire that worker, right? So the wage and the marginal factor cost can be equivalent to each other. Wage equals marginal factor cost. And that can be a really helpful, powerful thing. On the level that we would say marginal revenue equals demand, right? Marginal revenue equals demand for perfectly competitive product market. So let's calculate the MRPs for these. We have their marginal product, 37421. The good price is 20. So 20 times 3 is 60, 140. Boy, I had a brain fart. 80. 20 times 2 is 40, and 20 times 1 is 20. So you can see that the MRP rises and then falls. And a useful thing to be, why would that be? Well, because the marginal product rose and then fell. And so if we were to actually graph it, right, it would be kind of like you have this value of their marginal product and the quantity, and it would kind of do one of those, kind of an upside down marginal cost curve. Now, marginal factor cost, we already said, is equal to the wage. That's the cost of hiring each worker. So each worker is $30. And now we have the two columns that we need. Yes, I'm going to hire the first worker because 60 is bigger than 30. Yes. No, I'm not going to hire that fifth worker because the fifth worker costs me 30 and they only generate $20. So I would not hire them, but I would hire the fourth one. So I would say 4 workers should be hired because the last worker's MRP of 40 is greater than or equal to its MFC of 30. So again, I'm just kind of filling this out here. While the fifth worker's MRP of 20, that's coming from there, is less than the MFC of 30. So this is an explanation for why I would hire that fourth worker. Now let's take a look at how many of two inputs to employ. If you remember from utility maximization, we looked for where is their MU over P equal their MU over P, and we use the whole budget. We're going to use a very similar concept here, but in this one, instead of being about consuming, right, and having a budget for how much is going to leave us satisfied, from the firm's perspective, it's how many workers should I hire that are going to produce the most amount of stuff given my budget, right? So we're looking for the most marginal product per dollar, the most stuff per dollar that we spend on our inputs. And our budget is given to us here. We have wages, we have rent. And so the other way to think about what we're doing is cost minimizing combination of inputs. Another way to think about this would be if we're going to produce, say, 150 units, what's the lowest cost that we could produce those 150 units for? And that's another way that we're actually solving this. So you're feeding two birds with one stone. You are finding the cost minimizing combination of outputs, but you're also finding the most output that they could produce given kind of their money in that sense, right? Those are two sides of the same coin. So for each of these, we're going to take the rent, which is R equals 3, and I just wrote that here. We're going to take the MP over K divided by the rent and say, okay, 30 over 3 is 10, 20, 30, 25, 15, and 5. So I'm just dividing each one of these values by 3. And then I'm going to do the marginal product of labor divided by the wage, and the wage was 2. So 10 over 2 is 5, 60 over 2 is 30, 25, 15, 10, and 5. And now I'm looking for where are these two values the same. And I'm going to pick kind of one in the middle here. Let's try 15 and 15. It's been a while since I've done this. So the way we test them is we say, well, we've got a budget. Our budget's 18. Let's see. 15 and 15 corresponds with 4 workers. 4 workers would run me $8. And 5 machines would run me 15. Well, that's 23. That's above my budget. So I can't do that one. Let's move to the 25s, right? The 25s. 3 workers would be $6, and 4 machines would be, I don't know why, brain fart, 12. 12 plus 6 is 18, so they should hire 4 machines, and let's write it out. 4 machines and 3 workers, because 25 equals 25, and MP over R equals MP over W. If you forget and you wrote like MP over the price equals the marginal product over the price, you'd probably still get it right, but it's a good idea to make sure that you're also including this. We also probably want to say, and we used all $18. Right? That's probably in a little addendum that we'd want to put on there. So again, these two styles of problems, hopefully not too different about understanding the basics of factor supply and demand. I'll see you next time.